Welcome, I'm Sandle, and this is another video, slightly different one because I'm going to be walking around the Hertfordshire countryside, Hertfordshire in England, UK, and I'm going to be talking a bit about clean room controls, but in particular about fungal risks. And because I want to emphasise fungi in the external environment, it seemed better to go outdoors and make this video. So hopefully it's a little bit different and maybe slightly more entertaining, especially if I trip up or put my foot into a muddy puddle. Let's see what happens, shall we? Just as an example, we've got these kind of white spots on this tree here. So this could well be spots of fungal growth, I think. So within the clean room, fungi can be found in different spaces, and it's particularly those areas that we may not look at, like door kickback plates, between the step over and the wall, that odd bit of broken material, damaged vinyl, anything that's exposed. And it's these locations in particular that can be the most problematic. But the key thing I want to emphasise is the importance of identification. So the first thing with fungi, we have a few that are associated with the human body, particularly certain yeasts like Candida albicans. We also have trichophyton, which is the cause of conditions like athlete's foot and jock itch as well. So not the most pleasant things to scratch on about. Then there are the fungi that have a greater association with the as-built environment. Now, most fungi can colonise the indoor area, but there are certain fungi such as Cladosporium, which is one of the melanised moulds, and this can this is kind of like the black mould you'd find perhaps in your bathroom, and it likes damp conditions with a high level of humidity, obviously, and reduced levels of airflow. Then there's a whole host of fungi in the natural environment as we're walking through, but a lot of surveys of the types of fungi that end up in clean rooms tend to pinpoint certain levels of fungi, certain types of species that are more common than others. So Aspergillus, Penicillium, Alternaria are common grouping, and these are all filamentous fungi. They all have sort of medium-sized condia, and each hyphal mass that develops spore bodies can produce hundreds, sometimes thousands of spores that are fairly easy to disseminate in the air. And one of the risks, one of the continual battles, if you like, is this kind of constant fight that we have against fungal ingress into the clean room. Now, there are a lot of protective measures, obviously through personnel gowning and with the transportation of materials, and with the control of air as it goes into the clean room, see, through HEPA filtration. So if we think we're finding fungi through air ingress, then that's a normally an early sign that we've got a failure with our HEPA filtration. So this could either mean an integrity issue around the seal, or it can mean a hole in the HEPA filter itself. Another way by which fungi can enter the clean room is via the transfer of materials. Now this is partly influenced by the environment in which our facility is located in, but it's also a factor of the level of control. So materials will need to come from somewhere external. So there could be deliveries from the warehouse, coming directly by a lorry or other means. And all the external packaging is going to be contaminated. And some types of packaging are going to be at greater risk than others. And cardboard and its paper variants is a notorious reservoir for microbial contamination, including fungi. The important things are that when we receive a delivery of a material from outside, is that we remove a layer of wrapping as we're transferring the material into our facility. And I will be ideally doing this through an airlock, and ideally would have some kind of transfer process, some kind of agreed protocol between the people who are making the delivery, so say warehouse personnel, and the people who are receiving the delivery, so like production personnel. Now, when the material is in the airlock, we want to leave it there for a period of time. Now, the period of time we want to leave it there is to give it a degree of aeration, and the amount of aeration is partly going to depend upon how wet, damp our material is. So the wetter it is, the longer we need to leave it to dry, and we also position it in such a way that we have good air circulation. And so that means we're not positioning items, say, up against walls or under conditions that can maintain them in a sort of damp state. Then when we're kind of satisfied that our material is relatively dry, then we can begin the transfer into what is ostensibly our controlled, not classified environment. Once we've got our material in our controlled, not classified environment, then there's going to be a process of getting it into the clean room itself. And here at every stage, so that's from our CNC area through to our grade D or grade C clean room, or ISO class 8 at rest or in operational conditions, then we want to be removing a layer of wrapping and applying a sporicidal disinfectant. So both of those steps are, in my mind, very important elements of the contamination control strategy. And that becomes even more important if those materials are to see their way into a aseptic processing area, which could be another grade C area or a grade B area, depending upon whether we're using an isolator or a restricted access barrier system. To be really mindful that we're not passing in external contamination into the more critical clean rooms. And one of the important considerations that we will have is about reducing the risk of fungi associated with the external environment from entering our clean room space, because that's a fairly easy thing to get wrong. It's a fairly easy thing to make a mistake. So if we think we have concerns, then we should be conducting a contamination control audit. And this is a detailed step-by-step process. And here we just want to check that we have multi-wrapped items. And in any typical clean room cascade, we're going to need our items to be typically triple wrapped. Just because of the number of steps and stages we need. We may even need 4 layers of wrapping. Certainly 1 layer is never going to be any good. There may be circumstances where double wrapping is appropriate if we're perhaps counting the primary packaging as a tertiary wrapping, but in many cases even double wrapping is not going to be sufficient. We also need to be able to effectively apply our sporicidal disinfectant. So this means one, having a suitable sporicide, and not all sporicides are of equal efficacy. We also need to be able to apply that sporicide and to ensure we can wipe the sporicide over all of our surfaces. So spraying by itself is insufficient. We also need to be able to make sure that our sporicide is compatible with the types of materials that we're going to be using. So often that's going to be plastics, but we don't want the plastic to be inactivating our material or leaching out something that might allow microbial survival. And we also need to be able to distribute our sporicide over all of the applicable surfaces. And we also need to ensure that our personnel are able to apply our sporicide consistently and evenly, and have that level of understanding, that level of knowledge of what they need to do. And that's also really important, that the emphasis upon training and disinfection cannot be underestimated. This also places a important emphasis upon disinfectant efficacy testing as well, and we need to ensure that we've got a suitable range of environmental fungi that we can evaluate our sporicide against. And we can note also from the disinfection standards, particularly the European disinfectant standards, that we're actually using fungal spores, and also that we have spiny spores, which are the types of spores that are more likely to stick and become affixed to surfaces. So some suitable sporicides that we can consider include hydrogen peroxide, peracetic acid, or perhaps a blend of hydrogen peroxide together with peracetic acid. We also have chlorine dioxide or chloramine, but our choice of sporicidal disinfectants that we can meaningfully apply to the pharmaceutical context is always going to be slightly limited. Because we're transferring items from the outside inwards, we may need to target a greater log reduction of spores than perhaps we're considering within, say, our aseptic area. So within the aseptic area, we're probably looking for a 2 log reduction, but for items that are coming from outside now, the level of contamination could be relatively high, and although we can reduce that by removing certain layers of wrapping, we could still have higher levels remaining. So we're probably more here talking about 3 or 4 log reductions in order to get that proven level of biocidal kill. And of course we also have fusarium as another example, fungus. Now these are all filamentous fungi, microscopic fungi associated with trees and vegetation and greenery all around us, and clouds of spores are going to be in the air at any one time, although there is equally a degree of seasonality, and this is going to depend upon whether in the northern hemisphere as I am or in the southern hemisphere. But generally we can have peaks around the summertime or into the autumn as well. Winter we tend to see lower levels of fungal risk to our clean rooms. Okay, so I think that's everything that I wanted to get across. I'm Tim Sandle, and thank you very much for watching this video.